Welcome to your first lesson of trigonometry. You've watched that video and done the first sort of intro activity. Now we're going to start putting some vocabulary and some calculations into your learning. So to start off with, we're doing 6.1 angles in standard position in quadrant 1. So I've already alluded to in our previous unit the whole idea of quadrants having numbers. We're going to really dig into that in this unit. But to start, we need to define what standard position is. And so this whole piece here is talking about standard position. So we're measuring from the positive x-axis, and we can also use the distance from the origin. Okay, so it can be any point on our graph. So the coordinate plane is just our axes. And we're going to talk about how far it is from the origin. So the 0, 0. And the angle that it makes with the positive x-axis. So again, looking at this diagram here, the positive x-axis is looking at that right-hand side of the x-axis, the one where all our positive numbers go, and we're going to measure from there. So when the angle is between 0 and 360 is measured counterclockwise. So again, counterclockwise is going backwards from the clock in the classroom. Then this is standard position. So it's counterclockwise is the other key idea there. Okay, the line that actually goes from the origin to the point is called a ray because it's got an arrow. It's extending forever potentially in that direction. Okay, this is called the terminal arm. Okay, so the terminal arm, and sometimes we'll see that word side. I'm going to call it the arm though. And the terminal point is that point P. Okay, the positive x-axis is called the initial arm. We don't discuss this one in huge depth, but it's important to remember that that positive x-axis is where we always start from. So we need to note. And it's written there already, but just to really drive it home for you. That's not a G, again, that's counterclockwise. So we see this in the picture. We measure from our terminal side, but we can also create a triangle using this. So this would be point P, these coordinates. So we measure from the origin, 0, 0. R is our distance from the origin. And we measure our angle from our x-axis. We can then call our horizontal side our x side or initial side, and then y is going to be my vertical distance from my x-axis. So the Pythagorean theorem is a squared plus b squared equals c squared. We could rewrite this in terms of our variables in this picture. So we're going to be using this picture to complete this box here. So instead of a squared plus b squared equals c squared, we're going to say x squared plus y squared equals r squared. Sine is typically opposite over hypotenuse. If you don't remember, remember that it is SOHCAHTOA. And that's kind of our acronym for it. But now we're going to rewrite this in terms of our new variables in that picture above. And so it's going to be sine theta. Do not call it sin. Okay, it's a sin to call it sin. Sine theta equals, now it's going to be opposite. So we go straight across. So that's y over the hypotenuse across from my right angle. So that's r. I'll erase those so that I do the same for cosine. So again, cosine is adjacent over hypotenuse. But I'm going to rewrite it for my new triangle, my new definition. And so that's going to be x over r. Again, adjacent means beside. So we're not going across and passing through the middle. We're literally looking at what side of the triangle is making this angle other than our hypotenuse, because the hypotenuse is defined completely different. So adjacent is this x side. Tangent is finally opposite over adjacent, so OA. Okay, but again, rewriting it, we've got y over x. So those are going to be our new ratios. All of this information is going to be what we're kind of using for this unit. So I want to make note of that. That triangle, that definition triangle is super important as we move forward. And you'll notice that this kind of already looks familiar with what we did in that introductory activity. So use the diagram below to answer the following questions. R is the distance from the origin to P, where P is our point, and the distance is always positive. Okay, P is any point on the graph. So again, these two pieces of information are super important. So R is always positive and P is any point on the graph. So if we talk about R in terms of x and y, again, we're using that Pythagorean theorem where x is here and y is here. So we've got r squared equals x squared plus y squared. It's Pythagorean theorem. Or you could even rewrite it just in terms of r. We would take the square root of x squared plus y squared. Now remember, if we do this, we are always using the positive value. Never talk about a negative distance. Okay, because we're talking about distance, not displacement if you're in physics. Okay, I want to know theta in terms of x and y. So this is kind of shifted in my picture, but theta is here. Okay, so y is my opposite. X is my adjacent. So again, that means that we're talking about tan theta equals y over x. We could rearrange this, and if you recall from last year, we take the inverse tan to undo it. So this would be tan inverse y divided by x. But make sure that ratio is all together and it's not tan inverse of y and then divided by x. Some of those brackets are really important. Okay, the x coordinate in terms of p in terms of r and theta. So I want to talk about x, I want to know about r and theta. So again, this is the hypotenuse because it's across from my right angle. And theta, so hypotenuse, x is adjacent, theta, so that means I am using cosine equals adjacent over hypotenuse. But I want to write it in terms of x, or so that all my other terms are on the other side. So I would multiply by r on both sides. That cancels out. And so I'm left with the statement x equals r times cos theta. Now again, that dot can represent multiplication. Okay, those two things are synonymous. It's just so that I don't get confused with a multiplication symbol and an x. So I like to use the dot instead. My y-coordinate in terms of r and theta, I'm going to go back and do the same idea. So y is here, r, so y is my opposite, r is my hypotenuse, theta, opposite, hypotenuse is sine. But again, I want to get y by itself. So y equals r times sine theta. So these are going to be some equations that we're jumping back and forth to. You should be able to generate them on your own. But if you're someone that likes to memorize things, that is going to be challenging because there's a lot of different ways we can interpret these trig functions. It gets more complicated next year, but this is a good place to start. So those are just some general principles of our new definition of that triangle and measuring from our x-axis, specifically the positive x-axis. Example 2 looks at how to kind of interpret these. So the points below are on the terminal arm of an angle in standard position. Determine the distance r from the origin to P, determine the primary trigonometric ratios, and determine the measure of theta to the nearest degree. So I start by just kind of plotting them out. So 1, 2, 3, 4, 5. Again, you want to make sure that your scale is relatively even if you are just estimating it in here. And so 1, 2, 3, 4, 5, 6, 7. Put one more in for good luck. Make sure I identify x and y. Identify my scale. Now I'm going to go 5 and 7. So my point's going to be here. Maybe a little bit lower, a little bit brighter. It's a little bit challenging. Okay, and I will use a ruler to draw in my line. Now, unfortunately, rulers and this surface don't go hand in hand, so just work with me there. Imagine that that's a straight line, and this is point P at 5 and 7. Well, if that's the case, I can imagine that this is actually a triangle, and that this is my angle in standard position. From here, my y value is my vertical measurement, because it's up 7, so 7 here. My x value is my horizontal measurement, so it's going to be 5. So then I can identify r is here. So part A is just determine the distance. So I'm using that equation from part A in the previous example. So r equals the square root of 5 squared plus 7 squared. And again, you can put brackets around these guys, but because there's no negatives in this particular case, it's not necessary. As we move forward into the next lesson, brackets would definitely be a good idea. So we've got the square root of 25 plus 49. Again, you're welcome to skip steps, but I'm going to show all of them for this first one. Then I've got the square root of 74. Now, I don't know what the square root of 74 is. You could actually leave it right here. I know that 4 doesn't go into 74 evenly. I know that 2 does, but that might not help me. I can double check by going 74 and 1, or starting from 74 rather. I could prime factorize it, so that's 2, and then it would be 37, and 37's prime as well, so it would just have to stop. There's no perfect squares, so I'm just going to leave it as root 74. From here, I'm asked to determine the primary trigonometric ratios of theta. In this case, that means I want to know sine, cosine, and tangent. We're going to learn about 3 other ratios, but not this lesson. Okay, so sine, again, is opposite over hypotenuse. So we're going to take 7, opposite is 7 over the square root of 74. Adjacent is 5 over root 74. And tan is 7 over 5. That matches with my definitions up here of how I filled in my original equations, or we could even go back up to this box here. Last question is asking to figure out the angle to the nearest degree. You could do this with any of these. I personally recommend sticking with the one that all the values were given to you in the question. So if you made a mistake calculating that R value, we're gonna not have it impact our calculation in another question. So if that's what I'm going to do, I'm going to use tangent theta equals 7/5, or I can use the rearranged form up in the previous question. So that's theta equals tan inverse of 7/5. And I'm going to punch that into my calculator. Now, before you actually do this, please check your calculator to make sure it is in degrees, not radians. If you're not sure how to do this, ask me, go online, Google it. You can see that your calculator has a specific company name on it. You can search how to change radians to degrees on a Casio, and then you can put your model number because that's usually on the front too. Okay, but if you can't figure it out, you can always ask me or ask a friend that has the same calculator. Once you've done this, then we can type in tan inverse. Now, do not just punch the tan button. That is the tan function. The inverse function is usually like shift or second function and then press tan. And we're going to go 7 divided by 5. Make sure that that 7 divided by 5 is in brackets, so the tan inverse is affecting all of it. And we're going to get 54.5 degrees. Now it says actually to the nearest degree, so make sure you pay attention to what it's asking for. So instead of 54.5, we're just going to round up to actually round down because it's 54.4 if I didn't round it previously. So it'll be 54 degrees. That'll be my answer. So you can complete the same thing for part 2. Follow these steps. We can also use these standard position measurements for navigation. So a direction can be described by using a compass comparing north, south, east, and west. So a heading of west and then 30 degrees south means that we're measuring 30 degrees south from west. Okay, so if we look at example 3, a forest ranger sees smoke rising from a point that lies in the direction. And we always start with our coordinates, so never eat soggy wingers or never enter stinky washrooms. However you remember that compass points, we're going to go east and then north 40 degrees. Okay. She estimates that the distance from the ranger station is about 30 kilometers. Firefighters at the ranger station have to travel east, then north to get to the fire. So they have to go this way, then vertically up there. They can't go directly there. To the nearest kilometer, how far should the firefighters travel in each direction? So this is our X value and our Y value. You could also call it east and north if you want, just to help yourself out. The only problem with using a little e is that little e actually has a value attached to it. So I'm not going to use those. I'm going to use X and Y just to get in that habit. So to figure out X, this is my adjacent. So adjacent, this is the hypotenuse and my angle. So always looking for those ratios still. So this is going to be cos of not 30, but 40 degrees. It's going to be x over 30. So we can rearrange that and multiply by 30 to get it out of the denominator and isolate x. And now we've got 30 times cos 40. That gives me 22.98. So I'm going to go just to the plain old nearest kilometer like it asks, which is going to be 23 kilometers east. So that's one of my 2 pieces of answers because it asks in each direction. So I'm going to keep them separate. I've also got sine of 40 degrees because of my y value is my opposite. So y over, again, 30, multiply by 30 to isolate y in this case. And I get 19.28, so 19 kilometers north. That's my other measurement. And there you go. That's my answer. So you've got some questions to practice in the textbook. If you have any questions about the whole north, south, east, west piece, again, it's described up here. You see some language that you can use to talk about it. Toward the south, toward the north from that initial measurement. So this is like your initial heading. And then this is the direction you're going to rotate. So yeah, go to your workbook, do some practice questions, and then you can move on to the next lesson.